So we've got Marcel Zehner. I don't want to say it wrongly.
That's correct.
Yep. All right. No worries. Well, I'll hand it over to you to present on the death of the IT pros.
Thank you so much. So let me pull the screen. Can you guys see that?
Yes, we can.
Awesome. So welcome and thanks for having me. First off, unfortunately, my LED light just broke. I don't know why. So I hope you can still see me, but I'm pretty sure you're not interested in seeing me, but maybe more the presentation. So that should still work. So in the next, well, more or less 45 minutes, I will talk a little bit about the death of the IT professionals. And now, of course, every time I announce this session, people are like a little bit confused, or some even get like kind of aggressive, saying, well, what the hell are you talking about? Well, the thing is, it's more like I know, like a career planning session or an inspirational session. So it's not like a very tech thing. And of course, when I had the idea to talk about this topic, well, I first thought of, well, this session title here, which is change. But then, you know, if you speak at different conferences, you normally have to like send in some session proposals to get accepted. And if you send in a session with this title, people will not actually have a look at your proposal because it's just too boring. So I thought, well, okay, change is not good. So what about this then? So how to change to still be successful in the future as an IT professional? That's a little bit like better, but then again, it's not like a very catchy title. It's too long. Then I thought, well, what about this? Like transform yourself. But then myself, I don't like the transform word too much. And so at the very end, I ended up with the death of the IT pros. So quick information about myself. I'm Marcel. I'm a co-founder of Make It Noble. So we help customers with everything cloud computing. And when I say everything cloud computing, it's Microsoft cloud computing only. So we have like two divisions, one taking care of the Azure side of things. This is where I am. And another one who takes more care of the modern workplace. So M365 stack. If you have questions around these topics, I can probably not help you out there. I'm an Azure MVP, so I work with Azure pretty intensive. So I work with Azure customers, help Azure customers, or well, potential or future Azure customers to onboard into Azure, to help them like defining landing zones, define like their governance design, and then of course also like helping to transform their organization, their individuals, before they can finally run their workloads in Azure. And as you can see, I'm not from Australia. You can probably also hear from my accent. I'm operating out of CH, which stands for Switzerland. So for me, it's now 8:30 in the morning. Okay, but still a little bit too early for me. So I normally don't work that early. And as you can see at the very bottom in the last bullet, I'm an IT professional myself. So I started as an infrastructure guy, and talking about the death of the IT pros, I obviously survived. So I have some good recipes for you today, how you can survive this big change. All right. Well, just as a quick reference, you're down there. You probably know that. I'm up here in a very, very small country. And I normally do a little bit of research when I talk to like people outside of my country. So Australia is almost 200 times as big as Switzerland, but it only has 3 times the population, which is pretty interesting. And I also found out yesterday that we have 4 official languages. Well, I knew that already. And that's obviously 4 more than Australia, because Australia has no official language. I didn't even know that. That's what Wikipedia learned me yesterday. It seems the de facto language obviously is English, but it's not like the official language. Did you know that?
I assumed it was Australian English. That's what the Microsoft options are. So I thought they were
Yeah.
facing on there.
I assumed it was .NET, but fine.
All right. Good. So, but now let's focus a little bit on the death of the IT pros. I have to warn you. So I'm normally a very demo heavy guy. So I'm really a tech guy, and I love to talk about technology. But this is a demo-less presentation. So it's slides only. It's approx 50 slides. I made them. Well, I hope I made them a little bit entertaining. But I won't show any demos here. So the world is changing, and I mean that's not new. But we're like in a very big change for like several years already now. And if we take a look back a little bit, only like a few decades, we started with, well, in IT with something like this. That was before my time, of course. But well, at that time, we only had like several mainframes or several computers, big computers populating the earth, and only like very few people actually were able to operate those. And then some decades later, we saw like that change towards more client server networks where companies started to build like their own data centers. So they invested in hardware. They built their own data centers. They needed to learn how to actually design and build data centers. They need to learn about networking, how this works, about storage. Later came the word of virtualization, where we needed to learn about hypervisors, about segregation or segmentation of the network to make sure it's secure, and all of that meant like changes all the time. So change is not really new, and the same is also true for the software side of things, where we started with like programs living on these guys here on punch cards that were probably not very flexible, and we made a long journey when it came to software through whatever CDs and DVDs and so on. And now we live in a world where we can consume software from stores. So software is available all the time, and we can just like pick from thousands or hundred thousands of softwares and software components and have them available within seconds or several minutes. And again, big change, not only from the hardware side of things, but also in software. And again, that also meant for like software developers that they needed to adapt, they needed to change themselves, right? And change, well, it means that we need to learn about new things, that we need to, first see that there will be a change, and that we start adapting early enough that we are willing to learn and invest some time and energy into new stuff. And change is not like something bad. I mean, when I talk to some of my customers, they really don't like this change, because now the cloud is changing everything, not only from a hardware or software perspective, but also from an organizational perspective, how organizations need to reorganize to really benefit from the cloud. And changes happens everywhere. Also, for instance, and I just picked two examples, in Hollywood or in Hollywood movies, where we've seen like changes which are very good because it makes like movies better, more attractive, or Hollywood monsters more scary. Or also, for instance, here, that's a police car from Germany from back in the days, and now that also changed. So this is really good because they are probably more successful with that. So now, talking about IT change, or specifically cloud changes that impact IT professionals, I want to cover like 3 areas. And the first area where we see a big change now is changes in infrastructure. We know it, the public cloud is here. And I don't know about Australia. In Switzerland, we're normally not super fast. We now see like cloud adoption, of course, for several years, but it's really just starting now, where people and specifically companies see the value of the cloud, how it can help. And well, as we normally work with Azure, this is the Azure landscape, and that means that we need to somehow let go and move services that we used to run in our own data centers now, move them into, well, the Azure cloud, or that's also true for any other cloud platform, doesn't really matter. But again, that changes stuff, because that means that we don't need to care about infrastructure anymore ourselves. Because one day, maybe not today, not tomorrow, but one day, our data centers that we used to design and build and manage, they might be gone someday. And yeah, people need to start thinking about that. What does it mean if I'm like a storage specialist or a virtualization specialist? What does that mean for me in the future? So that will definitely change. Now, of course, in a perfect world, every service of a company lives somehow in the public cloud, but that's not, well, at least not for many companies, that's not the reality. So we'll end up in some hybrid environment where in the top middle box, you can see like some services might still run on premises, like on your local cloud or your own data center, or maybe you already like invested in things such as Azure Stack Hub or something to run your services, but they might still run in your own data centers, and you're still responsible for operating the services and operating the underlying infrastructure. But then on the left hand side, you see that then of course companies want to benefit from cloud services because they are available very quickly. They might offer services that you cannot consume on premises because you just don't have the compute power, maybe. And that means that they end up in a hybrid world, and hybrid world is, well, it adds additional complexity to the show. So managing a hybrid environment is very much complex. Why? Because you might have different processes, you might have like different APIs to manage your infrastructure, to manage your services. It adds more complexity when it comes to monitoring and so on. And this is also like a game that is changing now. And just to quickly mention it, you can see on this slide here that it mentions at the bottom Azure Arc, which is a service that Microsoft delivers to actually address this hybrid challenge, or the hybrid management complexity challenge, to allow you to, well, more easy manage hybrid environments in a very powerful way. So if you have never heard of this, have a look at Azure Arc. It's a very cool service. It's still in the make now, but it is definitely a game changer. So, but this is where we will somehow end up, or where many companies will finally end up, in a hybrid world where they consume services from on-prem from one or multiple cloud providers. Now, the second thing that's important for IT professionals is that we see a shift from capital expenses to operational expenses. Now, normally you might be more interested in solution and not in expenses or in the financial side of things, but this is now becoming more important. And why is that? Because if you live in the cloud world, every single configuration change that you initiate on your services might have direct impact on costs. So services can become much more expensive if you just like click something and tick one checkbox, and you don't think first, well, what does that actually mean? That's not so much the case if you do that on-prem, right? So this adds some more responsibility to, well, to your team or to yourself, because you need to understand how the billing model of those cloud providers, of those cloud services actually works, and think, well, if I do this change, what's the current impact? What does that mean from a financial side of things? And there's tools that of course help you. I just, well, brought a screenshot of the pricing calculator of Azure, just like as a proxy. I don't like the tool too much. It just means, well, you need to understand how public cloud services are actually priced, how the pricing model looks like. and you need to think about that before you actually make configuration changes. So this is some additional responsibility that moves over to IT professionals now that wasn't so true in the past. And also, this is not like mainly about infrastructure, but still somehow, I'm a Microsoft guy for more than 20 years now, so I always used to work with the Microsoft stack, mainly Windows and like other applications. But these days, there is a little bit more than just Microsoft and Windows. And I'm pretty sure that you heard this story where, well, Microsoft went through this big change from, let's say it a little bit nicely, not liking Linux that much to, well, these days where Linux is like a first-class citizen on the Azure platform, where Linux is like treated the same way as Windows is treated. So Linux is everywhere now. And it also means that, well, this fight, Windows versus Linux, is over. And we're now more in a world where we just want to pick whatever is best to fulfill our needs, to help our business or our customers. And it might still be Windows. It might be an application or an application component that runs on Linux. That's fine. But you will end up more in this hybrid OS world where you will see like multiple operating systems. And these days, operating systems are still very much important. That might change someday where the operating system fades from the spotlight and we can focus more on the application side of things and not on the operating system too much. But now this is still very much important. And if you see like the integration, how those two worlds are integrated these days already, I just brought some examples so that you can see that this is not just like a marketing slide or something, it's really happening. So for instance, we see Linux components running on Windows, but also the opposite. We see Microsoft components running on Linux. For instance, .NET Core or PowerShell Core that allows us to run PowerShell on Linux as well, so that it doesn't really matter if your admin workstation is like a Linux or a Windows machine. You should pick whatever works best for you, and you get like all the tool sets that you need to actually do your job, right? We have applications that are running on Linux. SQL Server is a very good candidate for this. But also, if you have like a mixed environment, you want to make sure that you have like this single pane of glass for monitoring when it comes to operating systems monitoring, which means that we also have the Microsoft monitoring agent that nicely runs on Linux, so that you can just collect data from those boxes as well and send it to your monitoring solution. And then maybe the last pillar here, Linux on Azure. Maybe you heard that already. There's more when we talk about infrastructure as a service. There's more Linux workloads now running on Azure than Windows workloads, because it's possible and customers obviously like it. So we see lots of Linux related or Linux-based services in Azure, such as, well, of course, Azure virtual machines that you can just, well, provision using a Linux operating system, such as Red Hat or something. We have container services that allow you to run Linux-based containers, and so on. So it's definitely a first-class citizen. It's integrated everywhere, and this is like the world we live in now, and it's great. Good. Now moving from infrastructure a little bit more to the application side of things. This is also very important. Even if you guys might be IT professionals and don't care too much about applications, this is becoming more important, because you will maybe end up in a team that is like responsible for provisioning, for managing, for monitoring applications. And this is why you also need to understand a little bit more about the application side of things. So one big change we see is that we move from a monolithic application architecture more to a microservices world. So what does that mean? In the early days, and I mean, that's still true today, we had lots of monolithic applications. So like this big beast where all the components were like glued together. And well, if you had to touch one of these applications for, let's say, installing like an upgrade or something, this gave you like some nights without sleep, because it was very, very risky. And these days we see more and more microservices approaches, where an application is, let's say, decomposed into multiple smaller components, which are microservices that will operate on its own, which gives you, like, from a risk perspective, like less risk if you need to maintain those services. That means that, well, you just touch a smaller component or a specific microservice and you don't touch like the full service. So the risk is like lower, and it also gives you much more flexibility, because you might have different teams that take care of these different microservices. They might be well, developed based on totally different technologies, which means whatever is best for a specific component, we select the best microservice platform to actually develop or design and develop that service. So it adds more flexibility to the thing, and it's a very, very good approach. But it also has a big downside, because it's not that, well, we just install an MSI on a server and the application is running anymore. So these times are gone someday. It's about, okay, let's take this application in production, and it means that we need to maybe develop and deploy 20 different components to make our full application work. So all of these microservices, they somehow communicate with each other if needed, normally through REST APIs or something. And that means that for our application that used to run on a single, for instance, a single IaaS server in the past, might now consist of 20 or 10 different resources in Azure that need to be provisioned, configured correctly. And only if like all of these individual services actually run in the very end, then your application will work as expected. So this adds more complexity, and it can become quite a challenge. It can become quite a challenge. So now, talking about these application components, we also see like new models, service models or application platforms that we can consume now, and it's important to understand those. Pretty sure that's not really new to you. And it's fun because someone asked for pizza in the chat, and I actually brought some pizza with me here in the deck, so you don't have to miss it totally. Now, why is there a pizza on the slide? Very simple. It's a very good analogy I found on the internet someday, and I normally use it to explain how this works. Again, this might not be super new to you, but imagine we talk about pizza now, and you want to consume a pizza after this meetup afterwards. Back home, then it's up to you to go to a supermarket and purchase like the dough, all the toppings, the tomato sauce and everything, and then go back home, prepare your pizza, and bake it in the oven as long as you want to bake it. So it's all in your control, from the purchase process where you select the cheese that you like, you select the toppings you like, up to the preparation phase where you add as many toppings as you like, add it into the oven and have it, whatever, a little bit darker, a little bit lighter, whatever you prefer. You're in control of everything. And then, of course, finally, you prepare the dining table and consume the pizza afterwards. So you're in control of this whole process, right? But then that also means that you need lots of skills, because you need to understand, well, how do I actually make a pizza myself? How does that work? What toppings do I need? So you need to understand all of this before you can start going to the supermarket and purchase the stuff, right? So you need more knowledge. And it also takes like some time. So you need to invest quite some time before you can finally consume your pizza. Now there's alternatives to this. So you could go for a take and bake pizza. So if you have no clue how to create a pizza yourself, or if it's just like too much time, you just go to a supermarket, take a pizza from the fridge, and then go back home and just add it to the oven and then finally consume it. That's also possible. But that means that you lose control of several steps or several layers in this process, which might be okay, but maybe also not, because if you want to be in control, then this might not be a good alternative for you. Now, if that is still too much work, there's also, of course, the delivery service that takes, again, some load from you, but also you are, again, less in control of this because the pizza is just delivered pre-baked and everything, and it's just served as it is served. So you have no control over it. You can still create and prepare the dining table in a way that you prefer, but all the rest is just delivered, right? You just consume it. And then the very last step is the option to not even call delivery service, but just go to an Italian restaurant. Maybe not now in these times, but normally you can go to an Italian restaurant and just like order a pizza and it comes pre-prepared. You don't have to take care of the table, the preparation of the table and everything. You just consume, right? And what's important here is, well, these are the options we have. And depending on our whatever daily mood, we might today decide to go to an Italian restaurant, but next week we might prefer to create a pizza ourselves. And the week after, we might just call delivery service to deliver the pizza. So it's not a one selection for all situations, but it's like whatever makes sense, whatever you want to consume now, you make the selection if you want to do like A, B, C, or D. Now, if we translate this into IT, it's the exact same thing. It's just like the layer names are not that attractive anymore. So if you have a look at the layers now, we just start from like the physical network, the physical storage, the physical servers, the hypervisor that we need to provision like OSs, which means virtual machines or containers. And then inside these OSs, we install something such as like a runtime or an application or an application component, or we just store data in there. But it's exactly the same thing. And if we translate this now to service models or IT services, this means the homemade pizza translates to a traditional data center that you run in your basement or something, or it might be your do-it-yourself cloud that you design and build and run somewhere, but you're in control of everything. The take and bake pizza means we don't have to take care about the infrastructure anymore here. That's delivered from a service provider, which in our case might be Azure. And this is where those terms IaaS or infrastructure as a service comes into play. And there we normally talk about virtual machines or containers. Delivery service, this is where PaaS comes into play, serverless architectures come into play, or also managed container services come into play, such as AKS, for instance. And Italian restaurant then somehow translates into SaaS. Now, why is this important? This is important to understand what I mentioned from, well, for the pizzas is also true for IT services. Not every service can run on the PaaS platform. Not every service is consumable through SaaS. And not every service might be preferred to run like in your own data center. So again, this is a by application or by service decision that you need to make. Is this running like on the SaaS platform, or do we want to run this in our own data center, or is this maybe something that goes into the Azure platform but still lives in a virtual machine? It's up to you to decide whatever makes most sense. But the most important thing is this, that your business or your IT consumers, they live on top of this stack, and they are mainly interested in applications they need to use and in data that they need to consume or want to consume. All the lower layers here are not of any interest to your IT consumers. No one cares what network components you run. No one cares about the hypervisor you use. No one cares about the operating system that you use to run their applications. And that means that our investment, most of our time, most of our energy, and most of our money, of course, should go in the upper layers of this stack and not in the lower layers, because there you don't generate any value. Of course, it's all needed to, at the very end, well, deliver an application, but it's much more important to invest in the upper layers. And this is something you need to keep in mind. And this is exactly where the cloud can help to deliver like commodity services so that you don't have to care, and so that you can focus on the upper layers and not on the lower layers. That's important. Now comes the downside, because of course, if you run like some applications on the SaaS platform, whatever, Office 365, for instance, or Salesforce or anything, consume some applications from there, then you have some applications that you built yourself that might run on Azure, for instance. Then you might run some applications that still live like in virtual machines, that some of them might live on Azure as well, but some are still living on your on-premises, in your on-premises data center. This means more complexity to provision and manage all of these different components. This is very complex. And that means that we need to somehow make sure that we don't lose control over this environment. And that's a challenge. I mean, of course, if you're like a small company with running 5 or 10 servers, it's not super challenging. But if you live like in a more complex environment where you really leverage cloud services to support your business, then this gets really, really important. And we normally say, well, it's easy to use the cloud, but it's very, very hard to master the cloud. Because if you want to master the cloud, you need to automate your processes. This is what I want to talk about a little bit now. That's the third pillar, which means procedures are changing, how you provision stuff. And the first thing is a discipline called infrastructure as code and automation. This is something that gets more and more important because of this additional complexity, right? And what's something I see a lot, a big mistake is when talking about automation or infrastructure as code, many people only talk about this circle, which means service provisioning. Well, let's write a script that provisions a service. And this is fine because that's needed, but that's not the end of the journey, because once this service, and it doesn't matter if it's just like one service living in a VM or if it's like a super complex service that's using a microservice architecture, once this service is in production, you need to maintain it, right? So that service might need configuration changes. You might need to add additional configurations or even components to the service. You might need to operate the service. Maybe you need to, whatever, restart your service, have a fixed procedure if the service isn't running anymore. Those kind of things also need to be on the list when you think about automating stuff. And finally, and that's normally the simplest of these three, is the decommissioning of a service. If it's not used anymore, we just want to kill the service and decommission it from our platforms. It's very important to think about the full life cycle when it comes to automation or infrastructure as code. Talking about infrastructure as code, this means that we don't use manual deployment procedures anymore. So we don't go to our Hyper-V server and start provisioning a new system by just clicking. We don't go to the Azure platform and use the marketplace to provision a new SQL database or something. We do everything as code from the very beginning. And talking about code, there's of course like several ways that you can approach this. So I just brought two quick examples. I'll not go into any details here, but this is a very simple Azure CLI script that obviously provisions a resource group in Azure and then a storage account and then a blob container inside the storage account. So this is a very simple example how infrastructure as code could look like. It's a so-called imperative approach. We call it imperative because it's a sequence of commands. So first line, create a resource group in this location with that name. After this has been done successfully, create a storage account with that name inside this resource group that we just created, and so on. So it's a list of instructions that we hand over to the Azure platform, and then it's hopefully done. And then there's this other approach that is called the more declarative approach, where we don't instruct the platform what to do and what to do next, but we describe the end state that we want to see. So we just describe, well, at the very end, I want to have a storage account, and that storage account needs to have this and this and this configuration. And you don't really care how this gets done. So you describe what you want. And then you hand this over to your platform or to your tool chain or whatever it is. And then that platform or that tool chain makes it so. Right? So you don't have to take care of the logic that is needed to finally provision stuff. You just describe what you want. It's a different approach. And this is also something you need to, to keep in mind. Well, what way do we want to go? More a declarative, more an imperative approach, or like a combination of both, which is, which gives you the ability to combine the best of both worlds, because there's no better approach than the other. Both have their ups and their downs here. Good, and that also means, of course, that this is something maybe you need to learn. Specifically, a declarative approach might be new to many people, and this is something you need to adapt first, to learn how this actually works, what the real value of a declarative approach is. And it will also maybe not be too easy in the very beginning. So you need to go through that learning curve. And of course, if you think of writing this code here that you see to just deploy a simple storage account, of course you might end up with, well, now I tried to deploy this 5 times, it failed all the time. Come on, let's just skip this and go to the marketplace and provision it from there, because from there it takes me 1 minute and then I have it. True, but if you see the full picture of that complexity I showed you, then this has definitely value in the long run. All right, so definitely don't only think about initial provisioning, also think about the maintenance of the service. And that's 2 things. So first is configuration changes, as I already mentioned. It's possible that you need to change your code. Maybe you need to resize some elements. You need to, whatever, if a firewall is included in your service, you might need to add new firewall rules, things like that. And using a code-based approach also gives you this flexibility to go to your code, change your code, and then test your code in some environment, release the code to your test environment, your integration environment, and see what the result looks like. And then if you're happy with it and you know it's rock solid, then you bring it into your production environment. This is not possible if you do stuff manually. And then beside the configuration changes that you might apply to your service, there's also operational tasks, such as whatever, restarting a full service that consists of multiple components because of some issues, whatever this could be. You need to identify the operational tasks and then also try to automate those, right? So it's configuration changes and also automating operational tasks. At the very end, it doesn't matter what tools you use. You just need to be comfortable and make sure that you don't lock in yourself somewhere. Good. And that brings us to another very important thing that also might change, because now if we really focus on doing stuff as code, there's another thing that gets more and more important, which is source control and versioning for your code. And I mean, we're still not developers, but we use developer-like approaches now. It's also code. It might not be C# code, but even if it's as simple as a PowerShell script, it's code, and you need to make sure that you understand how your code works. You need to understand, well, who did changes on that code. You need to make sure it's versioned and so on. And what I see a lot when I work with customers, especially with infrastructure teams, I see a lot of this. So, I mean, this is a little bit of history where you can see, well, this guy is obviously someone that invested in automation a little bit, and he's coming from like using batch files, and then he someday recognized, well, maybe that's not well, the de facto standard I should use. So let's go to VB-script, or finally, let's automate stuff using PowerShell, which is fine. But then what we see a lot is something like this. And I'm pretty sure this looks familiar to you, because well, people just start creating copies of their code before they do like any changes. They rename the code somehow, and this is not manageable anymore. For a simple script, this might be okay, but you don't want to release like code that you where you're not 100% sure that it will work, and you're not 100% sure that you use the right version of the code, and deploy this into a production environment that might impact your global service. So that doesn't work anymore. So you also need to learn about things such as source control and versioning, or source control management, where you have a system, a tool in place, or a platform in place that helps you changing, well, tracking changes on your code, and understanding the different versions that you had. So you can also go back to like older versions of your code. You see exactly what has been changed from version 1 to version 2, and so on, that this happens in a controlled way. And also very important, you want to somehow protect your code so that not everyone can just change the production code, the code that you deployed into the production environment. This is a very, like these are your crown jewels. I need to make sure that they are protected. One example that you can need for this is Git, for instance. So Git is a very famous SCM tool set that allows you to version your code, to manage your code. It supports distributed architecture, which means that you can manage your code in a repository in some central place, which could be, like in this case, Azure DevOps. And then if you need to make changes, you can just pull down this repository, then work on your code. And if you're well, happy with the result, if you tested your code in your test environment, then you can maybe push it back to that central place so that it's available to everyone else. And of course, there's like lots of functionality that lives in this platform that supports you with this process, such as protecting your, let's say, your production code through branch policies, for instance. And there's also this this concept of branching, where you create like a branch of the production code, so that well, if you somehow totally mess up your code, you just throw it away and it has no impact on your production branch. Then the second thing that's important, once you have like your rock solid code, it's managed in a very controlled way. What's also important is that you also release the code and apply the code to your platform in a very controlled way. And that means that it's not a good idea to then fire PowerShell scripts or Terraform configurations or whatever from your notebook, because the result might be a little bit different compared to if I release the same code from my notebook. Why is that? The code is still the same, true, but of course there might be like some environment variables that might somehow impact the release. So we want to make sure that we have a central place where all our code is released to the platform, no matter if it's Azure or your on-premises VMware platform, or it doesn't really matter where it is, but it's important to have a central place where you release your code. And again, I just brought a screenshot from Azure DevOps again that allows you to create so-called pipelines to release your code. And as you can see, the pipeline is nothing but a standardized process, so that you can make sure that whenever you release a new version of your code, it's released the exact same way all the time. So you have, like in this case, multiple stages. So for instance, you have like a staging environment or a test environment that you release your code first. Then, of course, before you release the code, you could do some quality checks, then release it. Then after it's released, you can do some tests to see, well, is the result actually what I expect it to be? Are the applications working? And only if all those tests are like successful, then you go to the next stage after, let's say, an automatic or even a manual approval, and then release the exact same code to the production environment. So Azure DevOps is a platform that allows you to build those pipelines. This, just for your reference, this is like the more, well, I don't want to call it legacy, but that's like the old versions of the pipeline we have. Because if we talk about doing stuff as code, you obviously also want to manage your pipelines as code. And there's these new multi-stage pipelines that you can also, of course, write and maintain in YAML code. This is more a graphical approach, just to see how this works. All right, so that's it. But there's a final thing that you also need to keep in mind. That's normally not something you might be in charge of, but what we just gone through, all of these changes, that also means that it has an impact on your organization as well, or it should have an impact. I see a lot of customers that, well, start using cloud services, but they're not willing to change their organization and still live with their old silos. And this doesn't work anymore. So I will not touch this in very detail because this is also not like my very main specialty, but the cloud definitely means that you need to change how your organization works. If you still have your classic silos, such as the storage admins and the Windows Server admins and the Linux administrators, you will not be successful in the future because, as we've seen, the application itself, the different components, this is in the center now, and we should build like our organization to really support this application centric view. So that means that we want to have teams that take care of developing, of provisioning, of maintaining, of operating a service with everything that belongs to this service, which means development, which means certain security things that we take care of, which means BCDR stuff, so disaster recovery, backup restore topics, and so on. And it's not, well, I'm only interested in storage and all the rest I don't absolutely care, as it maybe used to be in the past. So this will not work in a cloud world. I mean, it still works, but it takes a lot of benefits that you will get from you, and many organizations will not be really happy with that. So to sum this up, we've seen like the three main pillars that well, where we see changes now, which is infrastructure, applications, and also procedures. And now the big question is, well, how do you transform yourself to still be successful in the future as an IT professional? Four things or four bullet points I want to bring here. Whatever I've just showed you, make sure you understand this. This doesn't mean that you need to be an expert in infrastructure as code and in whatever Linux and so on, but understand what changes we're going through now, understand the world we live in, and just like be open-minded and learn a little bit about everything. And then, of course, still have your specialty where you really invest your main time in. But you should know about the things I've just showed you. Then what's also important, because you've done things in the last 5 years doesn't mean that that's still the way you should do it. So maybe rethink your old processes, rethink how you've done things in the past, and just check if that makes still sense in the future. And for lots of things, that is still true. So you can just like bring this over to the cloud and it will still work in the modern world. But there will also be things that just don't make sense anymore. And just really make sure that you challenge all of this, because now is the time and the opportunity to change those, right? So make sure you challenge all of that and then decide if you still want to use that in the modern world or not. Then what's very important, understand your business and customers, because that's the reason we actually exist. Everything we do in IT is to help and assist our business or our customers. And the better you understand what challenges they are facing and what they need, how you can help them, the more valuable your IT solutions will be, and the more valuable yourself as a person will be. Because if you can have this conversation with the business and then translate that into valuable IT solutions, this is where you can make a difference. Right. And finally, as already mentioned, become a T-shaped learner. That's how we call it. So T-shape means like think broad, learn broad, be like interested in lots of topics without being like the specialist in everything, and then like deep dive into some of these topics and invest there to become like the specialist to help your team with your tech expertise. And that said, I think if you follow all of these recipes, I think you are very much able to survive the death of the IT pros. I hope this, well, was somehow inspirational. There was something you included. And yeah, that's my message for the IT professionals. And as you can see, I transformed myself. I used to be that data center guy. So I used to work a lot with monitoring tools on-prem, designing data centers. And these days, my daily work is about infra as code, cloud governance, about processes, talking to the business, translate that into IT services, and so on. So it's possible. It's a journey. It's not done from today to tomorrow, but I think it's the right time to start. It's a very exciting journey, and I promise you will have a lot of fun. Thanks for your attention, and yeah, I'll still be around if there's some questions or if someone has like some additional inputs. I'm pretty sure that you guys have lots to contribute to this topics that I just showed you. Thank you so much.
Thanks, Marcel. That was really informative. Thank you. Do we have any questions for anyone? Feel free to either unmute yourself or just message in the chat, and then we can unmute you so you can ask a question, or even just any comments. Oh, waiting. I know me personally, it's something I need to work on a bit more. I keep looking at GitHub and my PowerShell code and go, I really need to set up GitHub. And then I open it, I start looking and I go, I need a lot more time to get my head around this.
Yeah,
it'll be a problem for later. And that's, yeah, you got to make that call sometimes, but you can't keep doing that forever.
Yeah, it's true. And you need to, you need to start somewhere. If you have a look at this session and you think, well, okay, if I'm on field 1 and how long does it take me to get there? Well, just go with baby steps. Just start somewhere, start adapting, and then continue from there. So it's really not something you need to rush through. It's lots of stuff. You don't need to invest into all of the topics you've just seen. It also, of course, depends a little bit on your role that you have, where your organization you work for is actually going. But it's a great journey. There's lots of opportunities out there, lots to learn, and lots of fun, of course.
We've got a question from Mike on the chat.
Yep.
He was just saying, hi, Marcel, I like your presentation and it inspires me to do a cooperation with you. His question is, which disruption will impact the life of the IT pro the most? Very open question for you.
Which disruption? So I think, well, again, it depends a little bit what company or what customers you work for. But what we see a lot with our customers, what impacts them most is that whole transformation from doing stuff manually to an infrastructure as code world. This is where we see not only like the biggest change, the biggest disruption, but we also see that this is the area where most of our customers are actually investing these days, because they see the value. If you talk to, let's say, to the C level, to the head of IT or to a CI or something, and well, you explain this concept of doing stuff as code to really be in control of software updates or application updates. Everyone understands this, and everyone is like, yes, this is exactly what we want. But then, of course, it's about the people that need to actually learn about this, because for many of them, this is brand new. I mean, some of them have, of course, experience when it comes to scripting, but when it comes to automating stuff in the cloud or even in the hybrid world, this is like new to lots of, at least for our customers. That's what we see. Yep. Does that answer the question?
We'll see if Mike responds. Is there a certain thing, I guess, in Azure that you think is a good thing to start playing with to get your head around, I guess, thinking that different way, like a certain type of service, or just start creating VMs, or
Well, as I said, go in small steps, and so I don't know about your background, but most of us IT professionals, well, they are pretty comfortable with everything virtual machines. So why not start there? You don't have to start with whatever fancy schmancy Cosmos DB service that you don't understand. So start with something that you do understand, such as virtual machines or networks, and then start working on deploying those kind of platforms as code. So start using, okay, how can I now deploy a virtual machine and the network and the firewall that I need to protect my virtual machines in Azure? How can I manage this, provision it, and manage it as code? Because then you don't know to invest too much time into learning what the service means, because you already know what the VM and the network is, and you can focus on learning about, okay, let's do this as code. How does this work with what I showed you, the Azure CLI, or with PowerShell, or with that declarative approach using ARM templates or something, and then start from there. Then continue with, okay, now let's bring this code into some repository managed things such as Git and place it on Azure DevOps. And then the next step would be, now let's deploy this. If I understand everything so far, let's deploy this through a pipeline and really go through these baby steps. But I would not encourage you to invest in these procedures, and at the same time in services you don't know yet. So start with something you understand, and to really focus on how to address this using code, using modern approaches.
Yeah. Is there certain things that you can't or shouldn't automate? Using like virtual machines building as an example?
If you ask me, no. But of course, at the very end, every automation comes with an investment, and at the very end, someone needs to decide, well, is this investment worth it? So how much does it cost to automate something compared to the number of times I will use it?
Yeah.
And at the very end, that's the decision. Well, what we normally do is, look, this is the value you get, this is the amount of time we need to do it, but it's finally the customer's decision in our case to decide, well, does this really make sense or not? But it's not only from, and that's important, it's not only about, don't only think about, well, if we automate stuff, we can deploy it faster. Also think about, well, we are more in control, so the quality of configuration changes will be better, so we might have less downtimes. If something happens to the service, and I can give you an example, we did a project last year for a local service provider that said, well, we want to stretch our offerings into Azure. They still have their own data centers, but they want to stretch their offerings to Azure. So it was lots about, well, infrastructure as a service for that specific case. So they built like a huge environment in Azure consisting of like lots of different networks, lots of firewalls, lots of NSGs and so on. And they wanted to have a solution just in case someone breaks something to really rebuild all of that within very short time. So it's also about those kind of things you need to think of. Well, would code help me if I do everything as code? In case of a failure or in case of an attack or something, just delete everything and redeploy everything from scratch within a very little amount of time. And this is actually what we built for that customer. So it's not only about becoming faster and to act cheaper, it's also about like quality of your services in the long run.
Yep, makes sense.
Chris, if you are playing around with automation on a platform which you do have a credit card attached to, make sure that you set limits on what can be spun up and things can be shut down. The last thing you want to have is bill shock from a runaway process that you weren't aware was continuing to spin up automation without a stop button.
Yes. Yeah, fully agree. Oh, that's a good input. So always, no matter if you automate or not, but specifically if you automate stuff, if automation gets triggered automatically based on some events, make sure that you're under control when it comes to costs. So you really have a good cost control or cost management system. Talking about Azure gives you the tools for this, but of course you need to set them up correctly and use them, right?
And honestly, this is the discipline that IT pros can actually bring to a DevOps environment, which is something that often the devs don't think about, but the IT pros are aware of infrastructure constraints and what happens when things run away. It's often their task to go down and try and fix it. So this is the discipline and the skill set that the IT pros can actually bring to help as a whole organizations take advantage of automation solidly.
Yep, absolutely. I fully agree, and that's also what we see a lot, because we let's say we see ourselves as a company between those two parties, because many organizations still have like the infra guys and the developer teams or whatever, and the classic thing, they don't speak the same language, right? And we see ourselves really sitting in the middle, because we can have conversations with IT pros, but we can also have conversations with developers up to a certain point, of course. And we see a lot when we work with customers, when devs are actually want to implement a new application, they don't care about many things that we as IT pros really care about. Well, might be costs, might be security related things. They're really focusing on application functionality, which is great, but that's not the end of the story. So really, to bring your application to like a controlled, secure environment, you need to add this IT pro expertise. And this is where those cross-functional teams comes into play, where you have like the devs, but also they need to be supported by IT professionals who really understand like the underlying infrastructure. So perfectly agree with that.
Cool. I hope that answered Krish's question around free platforms. If not, Krish, let us know. I hope I pronounced that right, but Martin's asked, or he's actually just made a comment. What helps me to get started with infrastructure as a code is exporting configurations of existing servers in Azure and viewing how specific settings have already been done in the code. So I guess doing it through the GUI, exporting it out, and then seeing how the code reads to do it.
Absolutely. So that's a good one if you want to start with ARM templates, because it allows you to create ARM templates already from existing services that you deployed into Azure. So let's say you deployed a virtual machine and it's running in Azure, then you can export a declarative configuration file from there that allows you to have a very, very quick start into infrastructure as code using ARM templates. Just be aware, you can extract those existing services into ARM templates, but you just cannot use them immediately. They need some like cleanup. You need to optimize them a little bit, but definitely you're 90% there. So that makes you very fast. Another good resource when it comes to ARM templates, just to let you know, is the Azure Quick Start templates on GitHub. So there's a GitHub repository. Search for Azure Quick Start templates, and in there you will get hundreds of examples of ARM templates to provision applications, from very simple examples to very complex services, totally for free. So definitely also have a look at that.
Cool. We also had from Gaber saying, Marcel, you mentioned you don't like Azure Price Calculator. Is there any other free tool you'd recommend instead? He doesn't personally like it either.
Yeah, well, not really a tool. When I calculate stuff, I just use the Azure Docs and the prices that are actually published there. But of course, it's not super convenient, but it gives you, like, of course, full control. So I'm not saying the Azure calculator is not good. I just don't like it too much myself. It's a personal thing, maybe.
Fair enough. That was all the questions that have come through on chat. Andrew or Brett, do you have any other questions or comments?
No.
Okay, we'll wrap up the main presentation. Yep, great. Okay, right. Wrap up my own presentation. Thank you very much, Marcel, for presenting that.
Thank you.
We've got some happy people watching that. It's definitely interesting. Hopefully, gives some people a bit of a push along to spend some time, adapting a bit. Ashley's just said, great talk. Looking forward to sharing the recording with a couple of like-minded colleagues. And yet, we've got the recording on Teams, and we'll post this to our YouTube channel once we clean up a bit. So thanks very much, Marcel. Really appreciate it.
Feedback as well. Please let us know about feedback as well, if you like this and so forth. We had a lot of people turn out today, which was a fantastic turnout. If there's anything else that you want to comment on about going completely online like this, or anything, please let us know. You know, it's a community. We want to know feedback, and we want to hear what you guys have got to say and what you think about this session.